everyone, and welcome to the latest video. This is a recording of what we've done in school this week. So if you're doing higher, it's Unit 41, Foundation Unit 44. It's all about multiplicative reasoning, and this is the third lesson. We're doing compound measures. Specifically, we're looking at density and pressure. So how this links into what we've been doing so far, we've done the repeated percentage change. That was the compound interest and depreciation stuff that we did first lesson. Then we started to look at the first of the compound measures where we looked at speed. So we did that last time. And this time we're going to carry on looking at further compound measures, and we're going to look at density and then on to pressure. Specifically today, we're going to look at what density is. Now, density, all it is really the amount of mass in a particular volume. It kind of tells you how tightly packed the stuff is that's within a given space. So if we show you something like this, we can see that the one on the left is much more dense than the one on the right. It's got a lot more going on, a lot more packed inside that same space. And the units that we use when we're dealing with compound measures tend to be something per something. So if we think about what happened with speed, it was meters per second, or miles per hour, or kilometers per hour. When we're dealing with density, we're looking at grams per centimeter cubed, and we're looking at kilograms per meter cubed. So again, there might be a little bit of conversion needed to be done, just like there was with the time. Again, just like with time, we did a speed, distance, time diagram, a little triangle, and for density, mass, volume, we're going to do exactly the same. So we're going to have density, mass, volume. This is really important, so if at this point you want to pause the video and get this bit jotted down, I suggest that you do so. And then we'll move on to look at things to look out for. So are the units consistent? So if you've got one thing in grams per centimeter cubed and another thing in kilograms, you're going to have to convert your kilograms to grams. If you've got one thing that's in grams per centimeter cubed and the other thing in meters cubed, you're going to have to convert your meters cubed. So it's really important that we end up with the same units to get the calculations correct. It might be that we need to actually work out the volume before you start. So make sure that you're happy working out volumes of cuboids, prisms, cylinders, that kind of thing, maybe spheres as well. And one final thing to kind of make sure that we're happy with is if you've got 1 meter cubed, so a meter by a meter by a meter, and we're turning it into centimeters cubed, remember 1 meter is the same as 100 centimeters. But that doesn't mean that 1 meter cubed is going to be 100 centimeters cubed. It isn't. It's going to be 100 times 100 times 100. So 1 meter cubed is 1,000,000 centimeters cubed. And one other thing just to kind of bear in mind at this point as well, in terms of volume, sometimes we're talking about volume in terms of liquid. And one further thing that might be useful is that 1,000 centimeters cubed is the same as a litre. Okay, so again, at this point, I'd pause the video. I'd make sure that I've got this, or at least these two things written out. These are the two important key things that we'll come back to later. So first example then, so we've got a cuboid with dimensions 9 by 3 by 12. It says it has a mass of 194.4 grams. Find the density of the cuboid. Now to do this, first of all, we're going to have to do a little bit of thinking about what density is going to be. So density is going to be grams per centimeter cubed. We're going to have to work out the volume of this particular cuboid. So we're going to do 9 times 3 to get the surface area, the area of the face, and then times it by the length of the shape, which is 12, and that's going to give us 324. And then from our density mass volume triangle, we're finding density, so we cover this one over, and we're going to do mass divided by volume. So we've got our mass, it tells us in the question, we've got the volume we've calculated, and we're going to get an answer. On our calculator, we get 0.6, and then we need to think about the units. Now, this was in grams, this was centimeters cubed. So my units are grams per centimeters cubed. Second example, again, we've got a cuboid. It tells us the density. We're going to find the mass, and we've got some dimensions here. So if we're going to find the mass, you cover over mass and you're going to do density multiplied by volume. The density is in kilograms per meters cubed. So when we're calculating the volume, this needs to be in meters cubed. So we're going to have to do a little bit of conversion first, making sure that this 2 is in meters. The 90 centimeters needs to be converted to meters, as does the 140 centimeters. So we end up with 2.52 meters cubed, and then we're finding mass, so we can do that value multiplied by the density, and that's going to give us 2.016. And again, let's just compare, think about what we've done. This is now in meters cubed. The density was kilograms per meters cubed, so this value is going to be in kilograms. And then finally, we've got a cylinder. It's got a mass of 270 grams, a density of 0.78 grams per centimeter cubed. The height of it is 9 centimeters. It then says find the radius of the cylinder. Now, I would always encourage at this point that you don't start to worry about the radius of the cylinder yet. I mean, we can start to draw ourselves out a little picture just to make sure that we're happy with what's going on. But I wouldn't worry about working out the radius just yet. I would very much consider what's happening if we've been given mass and we've been given density. With mass and density, we can calculate volume. So I would suggest that that will be where we start. Let's calculate the volume first. And the volume we can get as this. So 346.15 and so on and so on and so on. Now, how we actually calculated this, and what that is centimeters cubed at this point. Okay, so this is centimeters cubed. We're trying to find the radius of the cylinder. Now, the radius of the cylinder will also be calculated to get the same value here if we remember how to work out the volume of a cylinder. So, volume of a cylinder is pi r squared, which is the area of this, multiplied by h, which is 9. So actually we've got everything. We know this h, okay, so we know that. We know pi is just a value. The only thing we don't know is the radius, and that's what we've been asked to work out. So when we start to work it out, let's think about what's happening. So this volume is equal to pi r squared times h. If I know that that's the case, then this h was 9 and pi is just the number pi. So if I take this value here and divide it by 9 and divide it by pi, I get 12.24, and that's r squared, and I just want r. So I'm going to have to square root this, and then we're going to round it to something that's sensible. And I think the sensible value here would be 3.5 centimeters. Okay, so we're substituting in the values we know. We know that that's 9. We know that pi is 3 and a bit. And so therefore we can just do this on our calculator. Okay, what we're going to do in terms of practicing this is I'm going to ask you to draw out a bingo grid. So 3 by 3 bingo grid. I'm going to give you some numbers. And then you can cross them out on your grid as we go. Now, what you're going to have to do is just check that you've got the right answers. We can't really play this against anybody else, but we can still practice the questions in the same way as we did in class. So the numbers to choose from. So you want 9 numbers from here. I'll go through each question one by one, and then when you've got all 9, you can skip through to the next part. So make sure you've written down 9 of these values. Or alternatively, if you just want to practice the questions, you can ignore the first bit and just do question by question. Okay, here we go. So first one, find the density of a piece of wood weighing 6 grams and having a volume of 8 centimeters. Pause it, work it out, and here's your answer. So we are doing the density. So density is mass divided by volume. Next one. Volume is what we're working out of a liquid weighing 4 kilograms and having a density of 1.25 grams per centimeter cubed. Notice that this is in grams, this is in kilograms. So when we're calculating it, we're going to end up doing 4,000 divided by 1.25 instead of 4. Next question. A kilogram bag of sugar has volume of 625 centimeters cubed. What's the density of the sugar in grams per cubic centimeter? So again, we've got density. We want it in grams per cubic centimeter. It's currently in kilograms, so a bit of conversion first. And here's the way to do it. We're going to convert that to 1,000 and we're going to get 1.6 grams per centimeter cubed. Next question. Calculate the volume of a piece of wood that weighs 102 grams and has a density of 0.85 grams per centimeter cubed. Again, pause the video. If it helps each time, you can always draw out your density, mass, volume triangle so you can see what you're doing. And here's your answer. So we've got volume, calculate volume, so we're doing mass divided by density. Next one, the mass of a marble. Find the mass. So again, V, we're finding mass, so we're doing density multiplied by volume. Multiply the two things together once you've checked your units are right and get yourself an answer. Okay, so if you did do a grid, you can be crossing these off as you go. 50 kilogram bag of coal, estimated the total volume to be 28,000 centimeters cubed. What's its density? Again, be careful, look, grams, kilograms. So we're going to have to do a bit of conversion. Okay, and we're going to do 50,000 divided by 28,000, and that's going to give you 1.79 grams per centimeter cubed. Next one, find the density of material of pebble weighing 34 grams, which has a volume of this. So again, density, mass, volume, we're finding density, mass divided by volume, mass divided by volume. A conversion one this time. Oil has a density of 800 kilograms per meter cubed. Convert it into grams per centimeter cubed. Again, give it a go to start with, and I'll go through it in a second. So in terms of how many centimeters cubed there are in a meter cubed, that is 1,000,000. So we've got 1,000,000 here. And how many grams are there in a kilogram? Well, to get from grams to kilograms, we would times by 1,000. So that's a difference of 1,000 that way. And this is a difference of 1,000,000 this way. So because we're going from that to that, so we'll be going that way. And so when you do this, you're going to get the answer of 0.8 grams per centimeter cubed. So you need to divide by 1,000,000 times by 1,000. Okay, next one, block of lead has a volume of this, again, centimeters cubed. That's in kilograms. Your units, it wants it to be in grams. So again, think about your conversion and then do your density, mass, volume calculation. Again, 11.4. Statue made of metal, density 8 grams per centimeter cubed. Find its mass of a statue and its volume 30. Again, you've got 30 centimeters cubed here. This is centimeters cubed. So when we're finding the mass, we can calculate the mass in grams. Density, mass, volume. So I'm multiplying this time because we're finding mass. Next one, we've got an estimate of a statue in Sheffield has a volume of 4 meters cubed. The density of the material used to make the statue is 9.2. What's its mass? So again, this is 4 meters cubed or 4,000,000 centimeters cubed. And again, if you do this divided by this, you're going to get an answer, which is 36,800. Next, volume of a solid object is 5 centimeters cubed and its mass is 50. Calculate the density. So again, density, mass, volume. Calculating density, so we're doing mass divided by volume, which is 10 grams per centimeters cubed. Hopefully you started to get some bingos going on by now. Alternatively, if not, we'll keep going. So water of density 100 kilograms per meter cubed fills a pool. The mass of water is 35 tons. Again, there's a conversion here. Calculate the volume of the pool. So density, mass, volume. Okay, and your calculations, 35,000 divided by 1,000, so 35 meters cubed. Next one, cuboid of dimensions 4 by 5 by 3 is made of metal with a density of 10 grams per centimeter cubed. Calculate the mass of the cuboid in kilograms. Okay, so we've got 60 centimeters cubed. 60 multiplied by 10 gives you 600 grams, which then we're converting to kilograms right at the very end, so 0.6. Certain type of plastic has a density of this, convert the density into kilograms per meters cubed. So this is doing the opposite of what we did last time. Last time we were going kilograms meters cubed down this way. So we're going to have to do the opposite calculations. Okay, so here to here, you're going to have to times by 1,000,000, and here to here, you're going to have to divide by 1,000, giving you 3,000 kilograms per meter cubed. If you've not yet got bingo, there's only a couple more questions to go. A cast iron rod 2 meters long has a cross-sectional area of 14 centimeters squared. The mass of the rod is 210 kilograms. Calculate the density of the rod in grams per centimeters cubed. So lots to do on this one, lots of things to change. So cross-sectional area here, it doesn't really matter what it looks like. So this bit is 14 centimeters squared, 2 meters long, or better still 200 centimeters. That's going to get you the volume. We've got the mass, which again is 210 kilograms, or better still, this value. Okay, and so you should end up with 75 grams per centimeter cubed. Brilliant. Hopefully you did well on that one. We're going to move on now to look at pressure. I'm not going to spend a huge amount of time because it's very, very similar. But when we're thinking about pressure, we're thinking about the amount of pressure that something is exerting down. Now you can see a stiletto's got a very small amount of area here, whereas the elephant's foot has got a much larger area down the bottom. So when we're talking about pressure, we're talking about the area that's being exerted on, and also the amount of force that's being put down onto it. So pressure is really a measure of how much force is applied over a unit of area. It gets bigger if force gets bigger, it gets bigger if force is more concentrated, and it gets smaller if force is more spread out. And we use this type of a calculation. So our pressure, force, area triangle. Again, in your books at this point, I will be drawing this out, and we're going to do a few calculations using pressure, force, and area. So car of weight 6,400 newtons. Newtons is the value that we use when we're thinking about force. So 6,400 newtons has 4 wheels. Each wheel has an area of 80 centimeters squared touching the road. Find the pressure. So we're going to go pressure, force, area. Think about your triangle first. Then put the values in. So we've got a force at the top, an area, each wheel 80 centimeters. We've got 4 wheels, so 4 lots of 80. Do the calculations, get your answer, and notice your units. Again, compound units, newtons per centimeter squared. Newtons per centimeter squared is how we're calculating pressure in this case. 3 quick questions for you to try. So we've got Emily weighing 500 newtons and is wearing stiletto heels, which combined have an area of this. What pressure does she exert? Okay, so each time think pressure, force, area. So your PFA triangle. Next one and next one. So pause the video, have a go. And for the first one, we end up at 5 million newtons per meter squared. Next one, 62,500 newtons per meter squared. Final question, who would sink further into the ground, Emily or Nelly? Can you justify your answer? And the answer would be Emily because she's got more pressure. Okay, final thing for you to try then on this topic. I've taken the context out of these questions. These are ones for you just to practice. So give them a go, pause the video, I'll reveal the answers in a second. Okay, and here are the solutions to those questions. Give them a tick if you've done them correct. If you've not, get in touch and ask why, or ask if you pop into school. And other than that, we've finished. So compound measures, we've looked at speed, distance and time, density, mass and volume, pressure, force and area. Check on class charts, see if I've set anything else this week. I think there'll be a lockdown paper for you to do. And if you want any extension work on this, let me know because I can send some through to you. Otherwise, thanks very much and I'll see you soon. Bye.